scientist. My name is Jabari. I'm an instructor with the Minnesota Office of Science from Scientists. I'm also a geologist.
Hi everybody, my name is Sarah. I am also a geologist and also an instructor with Science from Scientists in the Minnesota office.
So Sarah, before I became a geologist, I don't know if I knew what a geologist was. So can you tell us what a geologist is?
Definitely. I also didn't know what a geologist was before I became one. So geologists are interested in studying everything having to do with Earth. So we study earthquakes, volcanoes, mountains, rivers, and everything in between.
It sounds like a really wide range of things that geologists can do.
Yeah, geologists can study a lot of different things. It's a huge range.
Since I don't get the opportunity to talk to geologists every day, I thought I would bring some of my favorite rocks with me and maybe show them off a little bit.
That sounds great. You know, funnily enough, I also brought my favorite rocks to show to you.
The first rock that I want to show off is a really interesting one and one of my favorite rocks that I own. It's actually two different rock types together in one. So up on the top part, we have an igneous rock, and then underneath that, we have a sedimentary rock.
Wow, that's really cool. Do you know how that formed?
Yeah, so igneous rocks come from volcanoes, and sedimentary rocks are formed by sediments. So this rock is about 1 billion years old. So it's a really old rock, and it comes from northern Minnesota. And what happened is about 1 billion years ago, the Earth's crust started to pull apart. And as that happened, volcanoes sort of built up from underneath, and then they erupted lava out onto the surface. And so this sandstone rock had been at the surface, and then lava got erupted on top of it and cooled, and now we have this igneous rock on top of the sedimentary rock.
That is really cool. I didn't know that there were volcanoes in Minnesota.
Yeah, thankfully we don't have many volcanoes anymore, but about 1 billion years ago we did.
Okay, that's good. I was worried that there was going to be one erupting right underneath me, but I'm glad to know that won't happen.
Yeah, I think we'll be fine.
Okay, that's good. So I wanted to share one of my favorite rocks with you. This is actually, it's a really tiny one. This is called dunite, and it's one of my favorites partially because it's really pretty. It's green and sparkly, but it also I think is really interesting, and there is a whole mountain range in Washington State that is made out of this bright green rock, which is really cool because there's green rocks everywhere. So this is one of my favorites, and I actually collected it myself, which is cool.
That is pretty cool. So why is that rock so green and sparkly? What makes it look that way?
Yeah, that's a good question. So this is actually made of the exact same stuff that the mantle is made out of. So this rock comes from deep, deep underground, miles underground, and the minerals or the different crystals that are in the mantle just happen to be green. And so they're a pretty heavy mineral, they're pretty dense. And at some point, a chunk of the mantle was basically just squished up to the surface when the tectonic plates crashed together and pushed this chunk of the mantle up to the surface and built a mountain range out of it. And that's how we get this mantle rock, green rock, on the surface.
So the next rock that I wanted to show off is actually even older than the last rock that I showed. So this
Wow.
is one of the oldest rocks in the whole world, actually. It's about 3.5 billion years old.
Wow, and the Earth is 4.6 billion years old.
Yeah, so this rock has been around for almost the entire history of the Earth, right? About 75% of the Earth's history, this rock has been.
Cool.
And this is a metamorphic rock. So it's formed by changing a different type of rock, and then it's subjected to a lot of heat and a lot of pressure. So this rock is called gneiss, but that's not nice like the way that you're nice to your friends. It's spelled Gneiss, and it's what's called a high-grade metamorphic rock. So it comes at really high temperature and really high pressure. And so this rock was originally an igneous rock, but it got buried really deep underground, and all the rocks around it pushed on it, and it made all the minerals inside of the rock kind of line up with each other. And that's how we get these sort of stripes of dark minerals and light minerals, is that all the minerals get squeezed from the top and the bottom in this sample, and then they all sort of end up getting turned to be the same direction.
That seems like it could make a really nice countertop. A nice countertop.
Very nice countertop. Yeah, this particular rock also comes from Minnesota, and it's mined and quarried, and people use it to make countertops and to make sort of the fronts of buildings are made out of this kind of rock. So in addition to being geologically interesting, it's pretty and has commercial use.
That's really cool. I have one more rock to show you, and this, I think, is actually my favorite rock that I own. This is a fossil, and it's a fossil of what's called an ammonite, which is a creature that is now extinct. And I really like this fossil because it has these really beautiful patterns in it, and I don't know if you can see on the video, but it's really shiny. It's kind of an iridescent color. So it's really, really pretty, which is a lot of the reason why I really like this rock.
So what kind of animal was it before it became a fossil?
So an ammonite is it's a creature that has a shell. It's a bit like a nautilus, if you know what those are, but it lived in the ocean. And a friend of mine actually picked up this rock in South Dakota.
So there was an ocean in South Dakota.
Yeah, it's pretty crazy, right? There used to be an ocean in the middle of the continent that the United States is on. And that's because during the time of the dinosaurs, which we call the Cretaceous period, the climate was so warm and the sea level was so high that an ocean actually flooded the North American continent. And then these little ammonites and other sea creatures lived floating around in this ocean.
Cool. So how did it go from being a living little floating animal to turning into a fossil?
Yeah, that's a great question. So this happened when the creature died, its shell kind of sank to the bottom. And in order for it to become a fossil, it has to get buried really, really quickly. It has to get buried by sand and other loose sediments. And eventually more and more stuff piles on top and keeps on piling on top. And it gets squished and compressed into what we call a sedimentary rock. So it gets squished so hard that it turns into a solid rock. And then eventually, we can, millions of years in the future, we've now pulled this fossil out of the ground so that we can figure out what the environment used to be like in South Dakota. So that's how we know there was an ocean in South Dakota.
It's really cool that rocks, in addition to just being pretty, can tell us a lot about the history of the Earth, right? This rock tells us that there used to be volcanoes in Minnesota, and your fossil tells us that there used to be an ocean in South Dakota.
Yeah, rocks are great storytellers. I love that. That's one of my favorite things about them.
Well, cool. Thanks for showing us some of your favorite rocks. Really enjoyed getting to see them.
Yeah, thank you. I enjoyed seeing some of your favorite rocks too. Super cool. All right. Catch you next time.